Okay, so I've opened a new blank VI. So here is the program. We want to measure the temperature in the two different cups that I will have at different initial temperature point using my data acquisition system that I have in the lab. I have two thermocouples that I had to build a circuit for so that I can amplify their voltage. As I said in the previous video, if you have a temperature sensor that can give you a temperature reading from 0 to 5, for example, volt DC, or some like higher volt DC, it's okay. But because my thermocouple can measure from 0 to 4 milliamp, I guess it's super small, and so I had to amplify it 100 times. So the reading that you will see here is in terms in around like 100 to 300 milliamp. And you need your data acquisition system. The data acquisition system type that I have here is an input type because I'm actually getting voltage and current signals, and I'm passing them to the computer. So these voltage and current signals are inputting into my data acquisition system so that the data acquisition system can send it to my computer. If, for example, I had an actuator valve to maintain the temperature and keep the temperature constant in my cup, then I would have needed an output data acquisition device too, so that I can output and I can send order to my external device, which is my actuator valve here. So I can send order to it to open and close. But right now I'm just acquiring signals, I'm just inputting signals, and I'm just reading signals. So I only have an input type data acquisition system. The program that I'm showing you, it doesn't matter if it's an input or an output, it works for both of them. It's really simple. So let's get started. On your block diagram, right click, go to measurement, and because when you actually purchase a data acquisition system, you have to install its driver. So once you purchase a data acquisition system and you install its driver, you will see this NIDAC one. If you don't have that one installed in your computer, I believe you cannot see that. So maybe you cannot just follow my step as I'm doing because you don't have the data acquisition system connected to your laptop or your drive. So you don't have to do it, you don't have to follow me, just watch the video. If you don't see the DAC assist here or an NI DAC here, that's because you don't have the driver installed in your laptop. So go ahead and choose the DAC assist here and put in your block diagram. So once it's opened, and as you remember, this is like blue. So this is an express VI, meaning that the National Instrument people already gathered, already built the function, and they added some GUI for it, so it's like easy for you to follow. You can do the programming yourself one by one. I don't feel the need to teach you that, and I don't think that is necessary and the purpose of this class. But if you really like to know exactly step by step what is happening, you can do that. But I think this Express VI is perfect and you can do a lot with it. And it's easy, so why should we make our life harder? So I'll just go with the DAC assist. As I said, I'm acquiring signal. I'm not generating signal because I'm only measuring temperature. So you go ahead and choose the acquire signal, and I have an analog input. So my signal is an analog input because it sends voltage signals, and it is a voltage signal. So let's go ahead and choose that, and then you will have this device number 1 here. And as I said, you in this data acquisition system, the USB 6009, you can Google it and see it online. This is USB 6009. As I told you, it has 4 pins, so 0, 1, 2, 3. So I can connect my thermocouple to either of these 4 3 pins, 4 pins. I connected them to number 0 and number 1. So let's go ahead and choose 0 for now and say finish. And then in here, it is asking you what is the minimum and maximum voltage that I should expect. And here, the way that I built my circuit is going to produce voltage from -1 to 1. And if it is negative, it means that it's colder than than the room temperature, which I guess is 25 degrees C. So, okay, this is weird because I have to be able. Okay, okay, it's here. Let me make this smaller. Okay. So in the configuration, we have chosen that this is an analog input voltage type, and I have defined that it is in this range of 1 to -1 volt. And you don't have to do anything else. It's always good to choose a differential type, because if you choose a differential, you will have the less amount of noise. And then here, the acquisition mode is going to be continuous because we are going to continuously measure the temperature. You don't have to change anything in the samples to read and the rate, because I'm going to show you that you will change it in your program. So don't do anything in here. But come to the triggering tab. No, not the triggering, sorry, the advanced timing tab. And here you will see 10 seconds here. This means that if the program doesn't acquire signal in 10 seconds, there is an error, and then send an error to the user and stop the program. I will always increase that to 100, for example, seconds. Because, for example, for my case, I'd like to measure data every 20 seconds. And for sure, 20 seconds is higher than 10 seconds, so I can never acquire signals. I don't want to acquire signals every milliseconds because it's going to be too many signals for me. And for my specific instrument, nothing is going to change in 1 millisecond. But I might see some change in 20 seconds or even in 1 minute. So I will increase this as much as it is needed in your program. If you want this to be 2 minutes, increase it to 2 minutes. But 100 seconds should be fine for now. And then click on go to configuration again, and come here and click on add, because I have another voltage signals. I have two thermocouples and they are both on voltage. If you had another thing, for example a pH transmitter which works based on current, you choose the current. But here both of my sensors are the same. And my second thermocouple is connected to the AI1, so I will choose that. Again, it's still in the continuous mode, the advanced timing are the same. So I have kind of built a function that can understand that I have a data acquisition system that is based on input and voltage, and I want it to acquire data below 100 seconds and in continuous mode. So I'll click on OK. You just wait for the VI to be built, because this is basically a sub VI in your big VI, so it just needs time to understand. It says that you have made this in a mode that the express VI has to be in a loop, meaning a while loop or a for loop. Would you like to automatically create the loop now? You will not be prompted again for this VI. You can say yes. And why it's needed is that you want to acquire signals. For example, you want to acquire signals during like 2 or 3 hours of the operation. You just don't want to acquire signals just one time and then be done. So that's why you need to have a while loop. I'm going to delete these parts for now, because depending on what we're going to do. So basically I only added a while loop here around the data acquisition system because I want my data acquisition system to operate over a duration of time. So before continuing more with this data acquisition system, I want to show you something else. So once you have downloaded the LabView, you will have a software downloaded with you which is called NIMAX, downloaded with the LabView. I talked about the NIMAX before. So let's go ahead and open this NI Max while I prepare my circuit here. And I have to also go and bring hot water because this is room temperature water right now. Yeah, if you go to device and drivers, like previously I showed you, I didn't have the NI USB 6009, but because I just installed the driver today in the morning, now I have this. So I have the data acquisition device in my device and interface. So if you click on it, right click and go to test panel. So whenever you have an instrument like a data acquisition system, a sensor, some transmitter, transducers, or whatever, input, output, always test and make sure that this is working before you build your program, because you don't want to build a program and see that this wasn't working. And once you open it, it will say that are you an analog input? Do you have an analog input or an analog output? I have an analog input because I have a thermocouple. I'm measuring something. I'm not sending signals out. And I have two thermocouples. One is connected to 0 channel and the other one is connected to channel number 1. So I choose the channel 0 right now, and I said that I'm expecting to see voltage from -1 to 1. And then if you click on start, it will start measuring voltage for you. And right now this is like room temperature thermocouple. This is 0, number 0. So this is it. So if I like move it, or if I have my hand on it, which is like colder, you can see the temperature will change. But because this is really cold, it's not going to change. But you can see that you are actually reading voltages, and it's like real voltage. So you have to test this part. So if I go to AI1 and I will test this one is also reading, and the voltage. And these two, because I have built my circuits for amplifying, they're not exactly the same. So that's why you have to calibrate it. But the purpose of this video is not how to calibrate it. You know, calibration is super easy. Measure the voltage, measure the temperature, get the point out, and go on and find the calibration line. You will do the calibration line for this specific test today. We need to do that. I'm not going to do it, but it's needed. But when you purchase a sensor from a company already gave you the calibration. It's saying that from 0 to 100 degrees C, you should see from 0 to 5 volts DC. So it already gives you the calibration. It's good to always double check, but you know it's calibrated. But this is a thermocouple that doesn't have that, and I have to amplify it myself. So this is something that I want to talk to you about. Always go to the test panel and test and make sure that your system is working. I will close this. I will build the program, and once the program is built, I will go and bring boiling water, and then we can see the temperature reading and all these things. So let's close this, and I will close this. Okay, coming back to the program. Okay, so coming back here. So we have the DAC assist here. Here you can see there are like several pins to the left and to the right. For sure, the data is going to give you the reading, the data that you get from your data acquisition system. Here, the first pin, it's called rate. Don't know why it's not showing. Yeah, rate. And the second is number of samples. And then you will have some other pins here too. And then you also have a pin which is called stop, and that's for stopping the data acquisition system. So what is there are three things that are important: the rate, number of samples, and then the data. These three, only these three is needed. So what is the rate? Rate is actually number of samples per second, and number of sample is actually sample per acquisition time. So So for example, if I go ahead and say create a control for both of them, for a rate and the number of samples. So you have to create two controls for these two. So if I type one here and one here, that means every second I will have one sample. But if I go ahead and say 1 and 10, that means every 10 seconds I will have one sample. So I told you that rate is basically number of sample per second, and number of sample is actually samples per acquisition. So for example, if you divide rate to number of sample, it's going to give you acquisition per second. So if I delete 1 over 10, and it means that I will have 1/10 of an acquisition per second, or I will have one acquisition every 10 seconds. So this is how it works. So easy. Just say that I will have one sample every 10 seconds. If I change this to 20, that means I will have one sample every 20 seconds. If I change this to 100, that means I will have one sample every 100 seconds. If I change this to 2, it means that every 50 seconds I will have one sample. I usually just choose this as 1 and choose this to whatever I want. I will choose 10 seconds right now. So that means that every 10 seconds give me one data reading. And this is important. For some application, you might need to read a lot of measurements over time. You can just change this too. If you remember when we were talking about like creating this data acquisition, this DAC assays, I actually clicked on to the properties and go to the properties, and here I told you you don't need to change anything in the rate and samples to read, because I actually updated them here. So it doesn't matter what kind of number it's written over there in the properties of the DAC assays. If you give a different number as a rate and number of samples as the control to your DAC assays, it's going to read those numbers as the actual reading, and it's going to operate based on that. So right now we are going to acquire one signal or one data every 10 seconds. And my signal, I want to create a graph indicator. So I can read the results in a graph. So this is a while loop, and I want this while loop to operate for a certain amount of time. So what I have to do is to, actually I think this is not right. I will delete this part. So you will come here and you go to the graph and you say waveform chart. You add this waveform chart and then you connect this to your waveform chart. I think this works better. Somehow I remember the other one didn't work. Anyway, you just add a waveform chart in the front panel, and then you connect your data to your waveform chart so you can see the voltage reading here over time. And this while loop is gonna run for a certain amount of time. So you basically want to measure temperature for a certain amount of time, and then you want to be done. So if you remember from previous videos, if you go to the timing and then choose the elapsed time express VI, and then you can create a control for the time target, and you want to see the elapsed time also. So you can create an indicator so you can see how time is changing and elapsing over time. So I'm gonna move this. And then you want to say that if the time has elapsed, so the green one, time has elapsed, if this is true, stop the while loop. So this is from previous video, you already know that. So let's go ahead and run this run this program for now. I still don't have any hot water, so don't expect to see high voltage. But let's go ahead and see if this is running. So I want to acquire uh, data, I will say every second or every 2 seconds. So you don't have to sit here and look if it's getting any data. And for 10 seconds. So for 10 seconds, every 2 seconds give me one data. And remember we have two thermocouples, so I should see two lines here. Yeah, these two thermocouples that I have, they're both at the same temperature, but because they are slightly bit different and they are not calibrated and all these things, you see that they are a little bit different in terms of the voltage reading. So if they were calibrated, I could add the calibration and then get the temperature out of them. So this works. So basically, I'm having two measurements out and I can see. But I don't know whether this one is thermocouple number 1 or if this one is thermocouple number 1, because I'm getting all this data into one form. But what I need is that I want to separate these two signals. And so how can we separate these two signals and have them in like separate arrays that are changing over time? So I'm going to talk about that now. So notice that the data here is like in the blue thick line, and it's a dynamic type of data that you can only see them in the like this waveform chart. So for example, if I create an indicator here, you can see if I create a numeric indicator here for it, and I bring it here, you can see like if I run this, um, it's only showing like one number for now, and I don't know whether which one of this number is, because we know we are having two numbers, but which one is this? So it's kind of confusing. So this is not good. You don't want that. You need to convert this dynamic type of data to some scalar kind of data or floating point kind of data so that you can differentiate. So this is how you will do it. You will come to the block diagram, go to the express VI, and then to the signal manipulation, and choose from dynamic data type and put it here. And once you open it, because this is an express VI itself, it says that convert the dynamic data to the 1D array of scalars, and that's what we want. We want to see a 1D array of scalars so we can differentiate between these two signals that we have. And we need a floating point number, which is true, and you just click on OK. Now if I connect this dynamic data type, and if I say create an indicator for me, then I will have an array of floating point numbers. You can see that this is like a thick line, which means this is a 1D array, and it's orange, which means that it's a floating point number. So now I can see my data. Actually, I can differentiate between them. So let's run them again one more time. So you can see like how I'm having two set of data every 2 seconds, and this is for number 1 and number 2 data points that I have. So this is actually exactly what we want, and this is what is good. This is what we actually are looking for. So now I have an array that one of the elements is my thermocouple, for example, number 0, and the other one is my thermocouple number 1. So this is perfect. But now I want to take this one out and this one out, and I want to have them in separate arrays, so at different time I can see what is the temperature of my first thermocouple and what is the temperature of my second thermocouple. So there is another function in the array which is called, this is called it's called index array. I keep confusing this with some other array, but yeah, you will get the index array function, and if you go to the help, it will say what it does. It says that it returns the element or subarray of n-dimensional array at index. So I want to get the first element out and the second element out. And remembering from previous video, the first element is always element number 0. And then the second element is element number 1. So remember, we are always starting from number 0. So let's create a constant for both of them. And now if I create an indicator, I should get the elements out. So this is element number 1, and here is my element number 2. And now let's run it. Actually, my circuit is not connected to anything right now, so the reading that you're measuring here is false. But I just want to show you how the array is working. So you can see first element is here, second element is here. So now I have them separated. So we have created a while loop with the DAC axis that the DAC axis can acquire the data, and this is an input data, so it can measure them in terms of voltage. And we have transferred this dynamic data type into a floating point 1D array data type, and we have now separated them both. So now we are having elements. I'm gonna delete these parts because we don't need to have all these indicators. But what we need is that we want to have an array of data which over time it's updating. Again, remember from previous video, if we want to have an array that is updating every time, we go and choose the build array function. We drag it down one time, and then I'm going to make this bigger. And what we need to do is that we will connect the element either to the bottom or to the top, depending if you want to fill it from the top to the bottom or to the bottom to the top. And then you will connect this to the while loop and create a shift register. And then you are going to create a constant of 0, so whenever you start, it's a 0. And we will do the same thing for the other elements because we are having 2 measurement. Exactly the same. So that I can have 2 arrays of data over time. So I'm going to create an indicator for each one of them so you can see what it is doing actually. But you don't need to create a ton of like indicator. But whenever you want to debug a program, indicators really work because you can see what's happening at each wire. So now let's run it one more time, and you can see these data are being filled for each different element. So we kind of like separated them. So notice 8.6 and 8.7, 8.6 and 8.7 here. So this is how they are being transferred. So 8.7 and 8.8, 8.7 and 8.8, and you can see like how they have been transferred. Okay, so let's delete these indicators one more time. The last thing that we want to do is that we want to have a time elapsed data also. So we will have a time data and 2 voltage reading data. So again, go to array. This time we can choose a matrix, and we can build a matrix, and we can drag the matrix down. The first element of this matrix, we want it to be our time, but the second and the third, let's see, is this the first one? Yeah. The second and the third are gonna be my temperature reading. We have to do the same build array function for the time too, and just really make sure if you're connecting the element to the top one, it should be the same for all of them. Don't do it differently because one of them is going to fill from top to the bottom, the other one is going to fill from the bottom to top, and they don't correspond to each other. So just follow the same path. And we will do the same thing for the time data too. So now we can build a matrix. First is time, second is the second column is gonna be our first temperature, and the third column is gonna be our second temperature. And then we can create an indicator, which is basically the matrix of our data over time. And now let's run this. You can see that this is updating every 2 seconds. So every 2 seconds from 3 to 5, 5 to 7, 7 to 9, and 9 to 11, and then it's gonna stop because it's already past 10 seconds. And why do we see 11? Why don't after 10 exactly it stops? Because this is every 2 seconds that is measuring. So every 2 seconds there will be another acquisition, and because the prior acquisition was at 9 seconds, after 2 seconds it's going to be 11, and then it's going to say if 11 is larger than 10 or not. So that's the reason that you will see 11 here, because the previous acquisition was at 9, and this while loop only operates every 2 seconds, because this is how we defined it here. So it's going to come here and then say first, like at 0 it's 0, and then it's going to say okay, it's 2 seconds, let's do one set of the data acquisition system. So that's when the while loop actually runs. So this while loop is actually running every 2 seconds. So if I add a waiting function, it's just going to add to that 2 seconds, and this is not nice. So you don't want that, because it's already waiting 2 seconds to acquire another signal. So now I will go and I will come back with hot water so we can test the program. Okay, moment of truth. I'm gonna increase this time target to 100 seconds, so I'll have enough time to see what's happening. And everything is on and it's ready, so I'll get my thermocouple. I brought water at 2 different temperature. One is about room temperature, the other is colder. So this is my number 1, and this is my number 0. Okay, so let's run it. So both of them right now, they are at room temperature, so you can see that the reading are really close. So I'm gonna put them at 2 different temperature. This one I have to hold. You can see that number 1, which is actually this one, which is in the hot, the really hot water temperature, went up, and now the reading on it, it's higher. It's like 10 times higher than the other one, which is room temperature. So I'll take this one which is at boiling water out. I'll take that out, and it should cool down, start cooling down. You can see that the signal is coming down. It's now reading 0.27, now 0.26. So it's cooling down and it's coming down to the room temperature. It will take a while because this is really hot right now. So it's gonna take a while for it. Now I'm actually like shaking it, and so it gets cooler faster, and you can see how this is like reading differently. Now if I put it back again in the hot water, it will start going up, and it will start measuring like 0.35 now again, so it gets hot. So yeah, this is what I want to show you, that you can acquire more than one signal out from your data acquisition system using DAG access, and you can measure your data, and then you can put them in the array function in the matrices, and then you can plot them, and you know, all these different things. The only thing that remains is that if I have a calibration curve, and I know the ratio of the voltage reading to the temperature with the help of a thermometer, I can put a thermometer in my hot water, measure the temperature of the water. I will measure it with my data acquisition system, what is the voltage reading, and I can get a curve. And then, you know, you already know better than me that you come to the numeric, use these functions, and transfer your voltage reading to the actual temperature reading. And then you can add another column here for temperature. So basically, you can transfer all this data in this element and temperature, or you can change them in the array themselves. And then you can have another column for the temperature reading using the build array and then the shift register. I don't have it because I don't have the calibration for this thermocouple, and I don't have a perfect temperature reading and all these things right now. But assume that you purchase a temperature sensor from a company, and it says from 0 to 100 degrees C, it reads from 0 to 5 volt DC, and then you can have this equation really easily into your LabView program. I hope this video is useful for you guys. See you next week. We're going to talk about MATLAB in LabView and image processing.